Okay, so today we're gonna review, kind of go over implicit differentiation. So what exactly is implicit differentiation, right? And how is that different from the differentiation we've been doing so far? All right, so when we say implicit, well, first of all, what is an explicit differentiation, right? So when a function is written in this form, right, this is called explicit. So a lot of the functions that we have dealt with are in fact explicit, right? Any polynomial, right, that we've seen, any linear function, right? So all of those are explicit. Okay, so those are examples. Even our, get this lighting right here, even our trig functions, right? These are all examples of explicit functions, right? So when we say implicit, we say that it's defined in terms of a one or more functions, right? So one kind of common function is, let's say, the equation of a square. All right, now this is not a function, but it is an implicitly defined function, right? In other words, I can solve for y to find one or more functions that describe this graph, right? So let's say that our goal here was to find the tangent line at the point 3, 4. All right, so we have the equation there. It's a circle, radius 5. All right, so let's say we wanted to find the equation of the tangent line going through this point. All right, so up to this point, we've only have done functions, right? X squared plus y squared equals 25. That is not a function. All right, it is a relation between x and y, right? So one thing we can do is we can solve for y. We could say, all right, well, let me go ahead and solve for y. Right, so we could say I'll bring over the x squared to the other side. Right, I could do that. I could take the square root. Right, and again, be careful here. When you take the square root, we get plus minus. You take the square root of a square. Don't forget the plus minus. All right, so we get plus minus, excuse me, square root of 25 minus x squared. Now, which one do we use, the plus or the minus? Since we're dealing with a function in y, positive y is on the top one side. So 3, 4, sorry, is in the positive y. So we're going to use the positive function to differentiate. Okay. So now we could take the derivative of this, right? So we'll take the derivative of this. We have, so let me come up here and rewrite my function. We have y equals to square root of 25 minus x squared. And now let me find y prime. All right, so power rule, 1/2, bring it out to the front. Then we get negative 1/2, so we get 25 minus x squared to the 1/2. Chain rule, multiply by the inside, gives me negative 2x. So we get y prime equals to negative x over square root of 25 minus x squared. All right. Excuse me. Okay, and then now we can plug in our point x is equal to 3, right? Our initial problem, find the tangent line, so 3. So y prime evaluated at x equals 3, we get negative 3, square root of 25 minus 9. So we get negative 3 over 4. So that would be our slope of the tangent line. and we have a 0.34. Okay, so we get y minus 4, x plus 3. Excuse me, x minus 3. All right. Okay, so that's how you would approach it by given an implicitly defined function by actually solving for y. All right, now as it turns out, we can actually save ourselves some time by approaching it a different way. All right, so let's take a look at another approach. All right, and that other approach would be the implicit differentiation. All right, so kind of what is not written, right? We simply say y, but y is a function of x. Right, it's what we call implicitly defined. Right, so when we do something like derivative with respect to x of x, that's the independent variable, so that would be 1. Right, but if I want to take the derivative with respect to x of y, well, y is some unknown function of x, right? Well, I shouldn't say unknown all the time. Sometimes I may know it, sometimes I don't know. Right, so I can write that as y prime. Now, all of the other rules of differentiation still hold. Right? The only thing you have to be careful of is you're always going to be taking the chain rule, right? Whenever you take the derivative of y, it's not just the derivative of y, it's derivative of y as a function of x, right? So when we have something like, let's say the derivative with respect to x of, let's say, y squared, the power rule still applies here. You'll have 2y, but the chain rule says take the derivative of y, which is going to be y prime. Because again, I don't know what that function of y is with respect to x. So that's the one thing that is going to change here whenever we're taking the derivatives with respect to x. When we take when we consider an implicit function, is all the other rules apply, right? The power rule, all the trig rules. You just have to make sure to apply the chain rule and then multiply it by y prime. All right. So for example, another example here. Let's say we had the derivative of sine of y, right, with respect to x. So the outer function is the sine, so the derivative of that is cosine. Leave the inner function alone, cosine y. Take the derivative of the inner function, which is y, and that becomes y prime. Okay, so now we can, oh my God, excuse me. Now we can approach the problem that we had before in a different manner, right? Now notice that it wasn't too hard finding the slope of the tangent line here. There was some work involved, right? But nothing too crazy, right? But we can actually simplify now this work by doing this implicit differentiation, right? So let me show you how we can do that. All right. So if we start off with this, okay, and instead of solving for y, I'm just going to jump right into it and take the derivative with respect to x to both sides. Okay, so this is with respect to x. So this one is 2x, right, the independent variable. The sum rule, so we just move on and take the derivative of this, and that's 2y. But again, here, be careful. Chain rule times y prime. And the derivative of 25, it's a constant, so we get 0 there. All right, and now I'm going to solve for y prime. All right, solving for y prime, we get negative x over y. All right, so notice how quick that got me to my result. No solving for y, no, the derivative was pretty straightforward. And if we want to find y prime at the point, what was it, 3, 4? So x is 3, y is 4. So look at what we have here. Our answers agree. X is 3, y is 4. So we get the same result, right, in a little bit of work. Okay, and now notice here, even when we're at this derivative, right, y is an unknown function of x, but in this case it is known, right? When I actually solve for y, that function of y is root 25 minus x squared, which is exactly our derivative here, right? That part there, that is our y. In this case now it's an unknown function. When we take the implicit differentiation, we still treat it like an unknown function. Okay, so they're connected as well, right? Now you might be saying, well, this is complicated. I don't really get this, so I'm just going to solve for y all the time. Well, as it turns out, that's not always a possibility, right? So this implicit differentiation is going to come in handy when, say, for example, we wanted to find y prime for the expression or the equation sine of x plus y equals to sine of x plus sine of y. Okay. All right. So this is almost impossible to find a solution for y. So I cannot find y equals to some function. So I'm just going to go ahead and start taking the derivative with respect to x. All right. This is a good problem here because they test us on our different rules of differentiation. Right. Notice here we're going to apply the chain rule. Right. And then the sum rule inside. Right. So the outer function, the derivative of sine, that'll be cosine. Again, leave the inside alone. And then multiply by the derivative of the inside, which is a sum, right? So the derivative of x is 1. The derivative of y, again, be careful, it's not 1. It is y prime. Okay? And now equals to, on this side here, we get the derivative of sine of x. That's our independent variable, so we can just go ahead straightforward, cosine of x. Right, over here, derivative of sine of y. Again, here we'll be careful. Cosine of y. Oops. Chain rule, the derivative of the inside is y prime. All right, now we're not quite done here, right? In order to finish a problem like this, I want to have y equals to and everything else on the other side of the equation. So we can distribute here. All right, and what I'm going to do is I'm going to bring whatever has a y prime to the left side of my equal sign and everything that doesn't to the right. So in doing that, we get y prime cosine of x plus y. I'll bring this term over to the other side. So minus cosine y equals to cosine x minus cosine of x plus y. All right, and then lastly, to finish up this problem, we divide by this quantity here. So we get y prime equals to cosine x minus cosine of x plus y all over cosine x plus y minus cosine of y. All right, and that is how we find the y prime. Okay. All right. So that's how some examples using implicit differentiation. Right. The next example I want to work on is the homework problem, the one where we have to find a pair of tangent lines. Right. So we're given okay. So we're given the point -2, 0, and then the implicitly defined function y squared is equal to 4x, right? And so we're told here, one thing to realize here, if you didn't realize, this point is not on the graph. All right, what we are told is that two tangent lines go through that point. And I would like to find what those tangent lines are, right? So let's take a look at a graph here. Let me bring this up here. Okay, so what you see here is the graph y squared equals to 4x and the point negative 2, 0. All right, so what we're asked is, so what do we need to find the equation? We need a point and a slope. All right, so I'm given a point, negative 2, 0. I don't have a slope, right? But I know it's a tangent, so I know there's a derivative involved. Right, so let's say we have y is going to be equal to m for the slope, and then the other point is going to be x plus 2. All right, and I'll add a slider here. Okay, and then notice here, okay, so what we're after is the point that makes it tangent, right? Not quite tangent, so I need to find out what point is tangent. Right, I notice there's going to be two of them, but for the second one, I'm going to use symmetry to actually help me out and find that second equation, right? Because if the tangent is somewhere here, then the other tangent line would be somewhere there. In other words, we'll have a negative m. Whatever I find m for the first one, then it'll just be negative m for the second one, right? And you'll see there, right, somewhere in there, it looks like our tangent would be. Right, but here I'm just kind of showing it. Now we actually do the work to actually find what that value is going to be. Right, now how do I do that? Right, so let's go back here to my work. Okay, all right, so what I'll do is, let me draw myself my graph here. So you get negative 2, 0. All right, and I'm looking for two tangent lines. Here, right? So I need to find out what those points are, right, in order to determine the tangent line. Okay, so what I'll do here is I'm going to, a couple things I'm going to do here. I'm going to rewrite this. All right, so the point here is unknown, so I'll say, all right, the point there is, let's say I'll call y to be some value a, right? So if y is a, then x from my equation here has to be a squared over 4. All right, and then this point here, using the symmetry of the parabola, the y value would be negative a. The x value remains the same, still a squared over 4. Okay, so now my goal here is going to become to solve for a. And once I do that, I should be able to find the slope, y prime, right? Now, how am I going to do that, right? So the way I'm going to do that is by remembering how I defined the slope, right? When I was in, or when we all were in algebra, right, slope was defined in change in y over change in x. And when we were in calculus, we called it, the tangent at least, was the value of y prime at a given point. Okay, so I can use this formulation, the algebraic one, by having change in y over change in x, right? So here the change in y would be a minus 0. Again, I'm using the y coordinates, a minus 0, and then the x coordinates, a squared over 4 minus a negative 2, which will just be plus 2. Okay? All right, so that would be the algebraic one, right? Now, what about the calculus one, y prime? Well, I can do that by taking the derivative, implicitly, of course, of this, right? If I take the derivative with respect to x, we get 2y times y prime over 4 equals to 1. Or in other words, we get y prime equals to 2 over y. And that's what's going to go on my right side of the equation, right? But again, what is y? Y is going to be the value of a. So we get y, or 2 over a. Okay, and now I have an equation in the variable a. So it looks like it's a quadratic. So now I just have to solve this equation. And so let me rewrite it with a little bit of simplification here. And then I'm going to cross multiply. All right, I'm going to bring this up here. So when I cross multiply, we'll get a times a. And then we get 2a squared over 4 plus 2. All right, let me distribute here. That's 4. And let me subtract a squared over 2 from both sides. So we get a squared over 2 equals to 4. All right, multiply by 2 both sides, and we get a squared is equal to 8. Or in other words, a is equal to plus or minus square root of 8. Simplify my square root. We get plus or minus 2 square root of 2. All right, and it makes sense that we get a plus and a minus, right? Because looking at our graph here, we have the positive one and the negative one. Okay, so again, this was not what the question asked. The question didn't ask find the tangent point, but it says find the tangent lines. But now I can do that, right? Because what is y prime? It's simply 2 over a. So the slope of the tangent line is going to be 2 root 2, or tangent lines, I should say, and negative 2 root 2. Right, so our equation reduces to y negative 2 root 2 x plus 2. Right. And also y equals the positive 1. So those are being my 2 equations of the tangent lines. So let's take a look. Let's go back to the graph here on Desmos. All right, and let me plug in my value for m. I say square root of 8. Sorry, 2 over square root of 8. There we go. And now we see we have those tangent lines, right? And I just so we clearly let me graph the point. So one of the points would be 2 comma square root of 8. So there's the tangent point. And the other one would be 2 comma negative square root of 8. So there you go. All right, that's how you would solve this problem. Okay, thank you.